Hello guys, this is May 2015, C1 question number 6. Let's start. So this question asks us to find dy by dx here in its simplest form, and we have a curve C which has this equation. So let's write the equation first. So we have y equals x squared plus 4 into x minus 3 everything divided by 2x, where x is not equal to 0, because if x is 0 then anything divided by 0 goes to infinity, so this is not defined for x equal to 0. But anyways, so dy by dx, now before you find dy by dx, it is always best to simplify this equation. So let's do that first. So to do that, I will open up the brackets. So I'll have x into x squared, which is x cubed, then x into 4 is 4x, then minus 3 into x squared is minus 3x squared, then minus 3 into plus 4 is minus 12, and then this is divided by 2x. So further, now we can simplify the numerator a bit if possible, but you can see that it's already, you can't further simplify the numerator because you have cube here, square here, x, and a number. So next thing is to divide, to open up this division. So we can write this same expression as this over 2x plus 4x over 2x minus 3x squared over 2x minus 12 over 2x. Now here you can simplify x once and then you have left with twice, then x and x goes, and 2 once, 2 twice, you have x gone with one of these x's, you're left with 1, and this is as it is, and then similarly you have 2 once and you have 6 here. Now you can write this as uh, x squared over 2 plus 2 minus 3 over 2x, or 3x over 2 minus 6 over x. And as I said in one of the earlier questions, it's best to bring the denominator into the numerator. If you have x in the denominator, you bring it up by using a negative power. So I'll show you. So you do like this, plus 2 minus 3 over 2x minus 6, and then this becomes x to the minus 1. This is why. Finally, we can find dy by dx as it is saying here. So you do that. That means you can differentiate individual terms now. So dy over dx equals, that means bringing the power in front and reducing the power by 1. So 2x, 2 minus 1 over 2. I just brought this 2 in front and reduced the power of x by 1, minus, then the plus this 2 is a constant, so it goes away. So you don't have anything. So actually we just straight away go to this minus 3. So 3 by 2 x can be, only 3 by 2 will be left, because x to the power of 1 x just goes away, because x to the power of 1 becomes 1 minus 1. So this is basic differentiation, where if you have a single variable left, it disappears, only the constant term is on constant part of the expression is left. Similarly here you bring the minus 1 in front, so you have minus 1 6x minus 1 minus 1. This 2 and 2 cancel, so you will have x to the power of 1, which is x minus 3 over 2, minus into minus is plus, 6x to the minus 2. This is your dy over dx. You can leave it here, or you can just bring this x to the minus 2 to the denominator. You can say, I can write it like this, 6 over x squared minus 3 over 2. So that's part 1. Let's look at part 2. Part 2 is saying find an equation of the tangent to C. C is this curve at the point where x is equal to minus 1. Now we know that for any general equation, so equation of a tangent is a line, right? So general equation of a line is y minus y1 is equal to m into x minus x1, where m is the gradient. Now with this topic, dy by dx is also a gradient. So in other words, if you have a tangent at a particular point to a curve, the dy by dx at that point is the actual gradient. So what we need is we need m and we need y1 and x1 and y1, right? Now x1 and y1, you can these x1 and y1 is any point on the line. Now because that line or the tangent is touching the curve C at x equal to minus 1, your x1 can be minus 1, and the corresponding y1 you can get by putting x equal to minus 1 into this equation. So step number 1, get x1 y1. Step number 2, get m uh, using dy by dx, and step number 3 would be to get equation using general formula. We use this formula. So let me just clean up the board and we'll proceed with this part. I'm gonna clean up the board a bit. So here I have the derivative that we had. Um, so yeah, recapping what we said is we need to find m, we need to find x1 and y1, and then use the equation y minus y1 equals m into x minus x1. That will give us the equation of the tangent we're looking for. So let's get m1. So m, we need to compute dy by dx at x equals minus 1 because that is the point. So we have the dy by dx equation, so let's put minus 1 in this equation. So we have minus 1 minus 3 over 2 plus 6 over minus 1 squared, which can simplify to minus 1 minus 3 over 2 plus 6. Now this, if I take the LCM between these, will become minus 2 minus 3 over 2 plus 6. This is minus 5 over 2 plus 6, and I can further simplify this as minus 5 plus this goes into this 12 over 2, so 12 minus 7, so 7 over 2. That is my gradient m. Now x1 I already know is minus 1, so then y1 can be achieved using this equation and putting minus 1. So I have minus 1 squared plus 4 into minus 1 minus 3. So I'm putting minus 1 for x here, and then you have 2 into minus 1. This, let's simplify this. So minus 1 squared is 1 plus 4, and minus 1 minus 3 is minus 4, and 2 into minus 1 is minus 2. So you have this minus 2 can go with this minus 4, you get 2, and then 4 plus 1 is 5, so 5 times 2 is 10. So our coordinates are minus 1 comma 10, and our gradient m is equal to 7 over 2. Now let's use this equation. Finally, y minus y1 is 10, this is y1, this is x1. So 10 is equal to, for m we have 7 over 2, x minus x1 is minus 1. So we have y minus 10 is equal to 7 over 2, x minus into minus is plus, so x plus 1. This 2 can be brought to this side, so I have 2y minus 20 equals 7x plus 7. Now it says we have to express our equation in this form. We have, which means everything is on one side and 0 is on the other side, on the other side. So let's bring these things to the left side. So you can get, so you can either bring this to here, this side, or this to this side. It doesn't matter. So let me bring this to the right hand side. So you will have 0 is equal to, you write the right hand side as it is first, then you write the opposite of this. So minus 20, it was this side, so when it comes to this side it's going to be plus 20. Similarly, it was plus 2y, when it comes to this side it's going to be minus 2y. Simplify it a bit, so you have 7x, this 7 and this 20 will make 27 minus 2y. So finally you can write it as 7x minus 2y plus 27. That is the equation to the tangent, and this is A, B and C. Thank you. Let's move on to the next question.